Bismillahirrahmanirrahim. Moving on to the section on Unicast routing protocols. Until now, we looked at the algorithms that these protocols use. Now we will see how we are making use of specific protocols to update the information in routers on a network. So we will be looking at three. We will be looking at the Routing Information Protocol, RIP. This uses distance vector. We have Open Shortest Path First, OSPF, based on linked state algorithm, and we have the Border Gateway Protocol, BGP, based on path vector. Now, before we go on to look specifically at each one of these protocols, let's look at the reason why we have these different solutions. Now, this is the internet structure. We have so many different networks performing so many different operations. We have some providers offering backbone services. So these are the core services on which other services are built. So this will form like, you could say, a pipe that connects the different networks. So it's performing a very important function. Okay, the function is very important because it is the backbone. On these backbones, you would have other providers relying. So you would have a provider network. So this could be Vodafone, Mobile, STC, so on and so forth. These providers could also provide, now these providers actually will provide services to other networks. Okay? So what we are talking about here is we have different domains. We have different companies providing the services of backbone, provider networks, customer networks, okay? Different companies, peer networks, different companies fulfilling the roles of these different types of networks. Now, it's obvious that the technology used by each company will be different. Some would like to use Cisco, some would like to use some other hardware technologies. Some would like to use LAN. A customer network wouldn't mind using a LAN, whereas other backbones, the backbone networks would use more high-speed technologies, more reliable high-speed technologies. So in this way, based on the provider and based on who the company is, the needs will differ. Okay? The requirements will differ, the needs will differ. Some companies may have a very small number of routers. Some companies that, for example, handle backbones, they will have a huge number of routers. And we can't use one routing protocol to provide the solution to all types of networks. Okay, that's not possible. For example, the RIP protocol, it doesn't work when the number of routers in the diameter exceeds 15. Okay? If the number of hops becomes more than 15, RIP is not a good choice. Then we will have to use OSPF and other protocols. So this is why, based on what the system is, we will have a specific solution inside the system. Solution in the sense different technologies, different routing protocols. Okay? So to simplify things, to make things easy, we identify each one of these systems as an autonomous system. Okay? We call each system an autonomous system. So these systems are independent in themselves. Okay? An autonomous system will be independent. It can run independently in itself. And you have in here different routers and different technologies. Each system could use its own routing protocol. So here you could have RIP, here you could have OSPF, okay? So what do we mean by intra-domain and inter-domain routing? When the routing is being taken care of inside an autonomous system, it is intra-domain routing. And when we are considering routing between two different autonomous systems, then it is intra-domain routing. Okay? And together, by using intra-domain and inter-domain routing, we can together make use of these solutions to find out a lot about other autonomous systems. So, for example, this router will first exchange information to know about its own autonomous system. So its routing table has been updated. This routing table can now be exchanged with R2 from another autonomous system. So now this router comes to know what's happening here, who's here, and this router comes to know who's here. So when all these routers, edge routers, exchange information with each other, they can share the information about their own autonomous systems. So we have intra-domain routing protocols, and we have inter-domain routing protocols. Okay? Different routing protocols based on the coverage that they are offering. In here, you can see the example. Again, we have 3 different autonomous systems. This autonomous system is having point-to-point WAN links to communicate between routers. Here, it's simple. It could be a simple LAN that they're using, and here it could be something else. Okay? And these routers are interconnected with each other so that they are able to share the information about each other. So we have routing protocols are classified as intra-domain and inter-domain. We have RIP, that is based on distance vector, and OSPF based on link state. These both are more suitable for intra-domain type of routing. Whereas we have BGP, which uses path vector. This is more suited for intra-domain routing. So this was the introduction about the routing protocols. In the next video, we will cover the routing information protocol.